The NASA telescope has struck again, discovering another planet that is even better suited for life than our Earth. It's incredible how many superworlds the new James Webb Space Telescope has already detected. Thanks to highly accurate spectrometer analyses, we are now approaching the moment when NASA will finally announce that a planet has been found that exactly resembles Earth and even supports life. In theory, the James Webb Space Telescope, or JWST for short, can detect traces of life on distant planets. This is done by perfectly analyzing the spectrometer of the atmosphere and environment of a planet outside our solar systems. From the analysis, scientists and space enthusiasts alike can see how much water is present in a planet's environment, what the atmosphere is made of, and what the surface temperatures of a world are. From this data, researchers can identify the first biomarkers that indicate the presence of life. The James Webb Telescope has already made some groundbreaking discoveries. Planets that are so similar to Earth, or that harbor so much water, that they could be even better suited for life than our own planet. Scientists call these optimally habitable worlds super-Earths. But the JWST can do even more. The most fantastic telescope of all time can theoretically even detect artificial light on a planet. To do this, it uses the MIRI spectrometer, which is so finely tuned that it can easily distinguish artificial light waves from natural ones. This puts us closer than ever before to discovering a second Earth and possibly other forms of life. The JWST, a technological marvel. What we have in store with this new telescope is truly a marvel. Imagine being able to see thousands of light years with a telescope stationed in Earth orbit and get exact exoplanet analyses. It is only since the mid-1990s that humans have been able to detect other planets in the cosmos. The problem with these distant planets is their size. Exoplanets are tiny and they do not emit their own light, which makes them very difficult to detect in the dark expanses of the universe. The JWST has been specially equipped with infrared technology for this purpose, which for the first time makes it possible to capture even the finest light traces from the universe. Now you might ask, how is that supposed to help detect exoplanets when they don't emit any light themselves? That's absolutely right, but researchers use a trick in which light does not play the crucial role. Stars are tiny even at great distances, and exoplanets often appear no larger than a grain of dust. Despite their small size, they are, of course, heavyweights that exert gravitational effects in distant star systems. And this is precisely what the JWST can measure with its spectrometers by precisely detecting the environment of the star. The effects of gravity can be seen in subtle variations in light, and they reveal a great deal about the planets orbiting a star. The other technique for detecting exoplanets is transit observation. When a planet passes in front of its star, it causes a minimal dimming. The JWST can easily detect even these faint dimming events with its sharp eyes. This technique is unique, and it has cost its builders a fortune. NASA, ESA, and the Canadian Space Agency, together with the participation of other nations, have raised an incredible $11 billion to make this technological marvel possible. With its gigantic honeycomb-shaped observation mirrors, this telescope can see further and in more detail than any other before it. Never before have we known so much about distant worlds, and Webb has now presented us with a hot candidate for an Earth 2. Is K218b the new Earth? What exactly has the JWST discovered that has got scientists so excited? K218b is an exoplanet about 2.7 times the size of Earth and about 8 times its mass. The JWST has detected it about 124 light-years away. There, the planet orbits a red dwarf star in the habitable zone, which means that it is at a perfect distance from its star to harbor life. Furthermore, the JWST has detected clear signs of water in the atmosphere of K218b, which has further sparked the interest of scientists. Water is an important indicator for life as we know it. Water worlds have long been considered rare in astronomy, but now more and more distant worlds are emerging where we can be sure that they have a water-bearing atmosphere and probably also harbor larger water deposits on the surface. K218b is located in the so-called Goldilocks zone, which means that liquid water is almost certainly present there. If this is the case, there is a very high probability that the planet also has some form of life. Scientists are painting a picture of a super-Earth that is possibly a blue-green wonderland similar to our own. A planet almost 3 times the size of Earth could harbor even more life and have landscapes and features that are difficult for us to imagine. The exciting question, of course, is how we would definitely prove the existence of life on K218b. Although MIRI found no evidence of artificial life, which would be a clear indication of higher life, we still don't know whether other species use light sources similar to ours, or whether other peoples may have developed completely different lighting techniques. In our search for other life forms in space, we must not forget that only microorganisms, simple life forms such as fish or snails, or creatures like dinosaurs or other fantastic beings can live on a planet. They would not produce any artificial light, and yet life would still be there. Researchers are currently working on a technology to use the fine spectrometer of the Webb telescope in such a way that we can theoretically detect signs of metabolic processes on exoplanets. This could, for example, mean detecting certain gases that indicate the respiration of land creatures, or being able to determine whether bacteria in oceans influence the atmosphere. Tatooine, planets with 2 suns. Who doesn't know Tatooine, the famous planet from Star Wars with 2 suns? 2 suns are not as rare as we might imagine. Binary systems are actually quite common in space, and we even know of systems with 3 to 6 stars. Imagine a world illuminated by 6 suns. That would be bizarre and incredibly fascinating at the same time. Scientists have now found a class of exoplanets that are clearly gaseous and about the size of Jupiter. These exoplanets always orbit 2 stars, with some of these planets being very close to their stars. This makes them extremely hot, and they certainly have temperatures that probably make life as we know it impossible. Nevertheless, researchers are keeping a particularly close eye on these Tatooine worlds. We could indeed come across things that have not yet been within our knowledge. Space repeatedly shows us that we humans often still have a very narrow focus when it comes to exploring alien worlds. Earth 2 directly opposite, Proxima Centauri b. Did you know that a privately funded project is currently building nanoships that will be the very first man-made probes to fly to a distant star system? The special project called Starshot Breakthrough plans to send an armada of tiny probes to the Proxima Centauri system, 4.24 light-years away, in a few years. A few years ago, the exoplanet Proxima Centauri b attracted attention there. It was clearly identified as a rocky planet and showed ever more astonishing similarities to our Earth. A second Earth just around the galactic corner would have been sensational. After the initial enthusiasm, however, doubts arose. New measurements showed that the planet, which is slightly larger than Earth, orbits its star so closely that it probably cannot be a new Earth after all. The fact that Proxima Centauri b is very close to the red dwarf Proxima Centauri was initially not an obstacle to life because red dwarfs emit far less light than our sun. In the case of Proxima Centauri b, it is a different problem that has significantly reduced the prospects for life. Namely, researchers observed how the red dwarf star sent violent flares in the direction of the planet for a period of time. The star's ejections were so strong that the radiation on the surface of Proxima Centauri b makes life impossible. Nevertheless, the Starshot project still considers it possible that life exists there, or at least that this planet is so interesting that we should take a closer look at it. The Proxima system is thought to have other planets that would also be worth a look. Furthermore, we humans need to work on technologies that will enable us to explore exoplanets in more detail. The spaceships, which are only a few centimeters in size, will be equipped with mini cameras and some important sensors. Using a special technology, researchers hope to accelerate the starships to almost the speed of light. This would mean that after a flight time of just over 4 years, the mini probes could examine an alien star system for the first time. Ross 128b, even better prospects for life. If Starshot Breakthrough's plan works, we could also send probes to the planet Ross 128b, which is 11 light-years away. This world is also almost a twin of the Earth. The planet is only slightly larger than Earth and also orbits a red dwarf star. However, observations showed that the star, Ross 128, is much calmer than Proxima b. This means that Ross 128b is likely to receive far less radiation, and the planet is in the habitable zone. Scientists are currently waiting for the first real observational data on this planet to be provided by the James Webb Telescope. We currently know of more than 5,000 exoplanets, only a small proportion of which are Earth-like. There are many types of planets in the universe, some of which resemble our planets within the solar system. Others are bizarre and unusual. Planets of the Jupiter class are just as common as Saturn-like planets or worlds that resemble Neptune. In our search for life in space, we naturally focus on the rocky worlds. These planets are usually much smaller and therefore harder to detect. Nevertheless, we have a list of almost 30 planets that could be extremely similar to our Earth. The Webb telescope must now gradually work through this list and provide us with detailed spectrometer analyses of all these worlds. Only then can we say with certainty where there is water and where we need to look further if we ultimately want to find other life forms in the universe. Subscribe now and never miss a new video again.